Hi, in this video we are going to talk about breadth-first search, so let's get started. What is breadth-first search, or BFS? This is the most important graph traversal algorithms besides depth-first search. We visit every vertex exactly once, and we visit each neighbor vertex and the neighbors of these new vertices, so the running time of the algorithm is linear, which means it's ordo v plus e, where v denotes the number of vertices and e denotes the number of edges in our graph. So it has to store a lot of pointers, so it is not as efficient as depth-first search, but it has lots of applications. And we store these pointers in a abstract data type, a queue for example, and maybe we are going to talk about quite advanced algorithms such as A-star search or iterative depth-first search, because both depth-first search and breadth-first search has disadvantages and some advantages, and iterative depth-first search, for example, tries to combine the advantages of both depth-first search and breadth-first search. So the main disadvantage of breadth-first search, to be clear, is that we have to store a lot of pointers. It constructs shortest path tree, so Dijkstra shortest path algorithm does a breadth-first search if all the edge weight are equal to 1. So that's why it's good. So how does it look? We start at the root node, for example, but it's very important to consider that the graph is not always has a tree structure. So if it has several edges and lots of vertices, and each vertices are connected, then we can use breadth-first search, not just for tree-like structures. But here we are going to illustrate it with the help of a tree. So we start at the node, and we keep visiting its neighbors. So we keep iterating layers to layer, and we keep going deeper and deeper. So we visit its neighbors, 2 and 3. And then we store the references for 2 and node 3. In this case, node 3 doesn't have any children, so we keep going further down and visit the left and right children of 2. So 4 and 5, and then we are going deeper and visit the left child of 4, which is 6. And the graph has been traversed. So breadth-first search in artificial intelligence and machine learning, it can prove to be very important. I mean, this graph traversal algorithm, because robots can discover the surrounding more easily with breadth-first search than depth-first search. As you will see, depth-first search tries to go as deep as possible on the first time, and if you consider the fact, for example, we want to visit, we are at London and we want to get to Paris, so we want to traverse the graph, and depth-first search may go through Tokyo, for example. It's go very far away from the destination before reaching Paris. If you are familiar with the location of these capitals, it's not so efficient to use in these kinds of situation depth-first search. It is also very important in maximum flow problems. For example, the Adamant-Scarce maximum flow algorithm uses breadth-first search for finding augmenting path. That's so important. And the Kayan algorithm in garbage collection, for example, the Java garbage collection relies heavily on this algorithm. It's similar to mark and sweep garbage collection procedure. It helps to maintain the active references, and it uses breadth-first search to detect all the references on the heap memory. So sometimes it's very important, unlike the fact that it is very memory consuming. Okay, so thanks for watching.